mode of instruction is going to be about counting principles. So we want to look at how to count possible outcomes using the fundamental counting principle, permutations, and combinations. The reason why is that counting is needed in probability and helps us determine what and how many of things that might happen to plan for. I want to start by illustrating that when we use the word choice in common conversation, we could mean choices are decisions, but we could also mean choices are options. However, in the world of counting, mathematically, decisions are not options. And so we have to be really careful with our use of the word choice. And I generally prefer to substitute either decisions or options so that we can be more precise in communication. So this counting confusion means we have no choice but to vary our vocabulary. Therefore, we will not use the word choice. We will be precisely talking about decisions or options. So the decision is the act of deciding what option to go with. So please keep that vocabulary in mind. When we count possible outcomes, we need to know the available options for each decision. So here's a definition. Two decisions are independent if the outcome of one decision does not change the available options for the other decision. We have a couple different examples here. Choosing to buy a Nintendo Switch or Xbox and choosing to buy a new video game. So notice that our first decision is Nintendo Switch or Xbox. And our second decision is a new video game. And so these two options, or excuse me, these two decisions are independent, or excuse me, these two decisions are dependent because the games differ by console. If I want to buy a Mario game, for example, I need to go with a Nintendo Switch. But if I wanted to play Ori, I could play it on Nintendo Switch or Xbox. Same with Cuphead. The second example says choosing to eat pizza or a burger. So pizza or burger is first decision. Second is to drink water or soda. And these are independent. Food choice does, I shouldn't use that word choice. So the food we eat does not change the options for our drinks. It might change our preference. For example, you might really like the clean, refreshing coolness of water when you have spicy pizza, or you might like the tingling sensation of soda when you have pizza. But regardless, that is a personal preference. It doesn't mean you can no longer decide to have either option. So therefore, these are independent. The fundamental counting principle, that part's not quite needed when we're doing this as a video. So the fundamental counting principle says the total number of outcomes for multiple independent decisions is the product of the number of options for each decision. To state this technically, in very precise mathematical language, if one event can occur in m ways and a second event can occur in n ways, the number of ways the two events can occur in sequence is m times n. So the number of outcomes for the first decision, the number of outcomes for the second decision, you multiply them, and that gives you the total number of outcomes using the number of options for each decision. So let's do an example or two. So let me do blue for this first one. A new lunch special at El Señorial, which is a local restaurant, has the following options: chips with salsa or guacamole, 3 tacos or a torta, and coffee or soda. How many ways could you have lunch? So this is an application of our fundamental counting principle, which I often abbreviate FCP. We have how many choices, but before we get looking at our number of options, again, not using the word choice, we should discuss how we know that these are independent. So regardless of whether I get chips with salsa or guacamole, it doesn't change the options for my other decisions. Therefore, they must each be independent. It might change my preference, but preferences are not options. So chips with salsa or guacamole, that's 2 possible options. Then 3 tacos or a torta, this is another 2 possible options. And then coffee or soda, this is yet again 2 more options. So by the fundamental counting principle, the number of ways we could have lunch with this special is 8. So there are 8 distinct ways that we could have lunch, deciding on each pair of options. Example 2. A new locker system uses 2 letters, A through Z. Both letters may be either the same or different, and 1 number, digits 0 to 9, in that order to unlock each locker. How many different lockers would the system allow a school to have? Or a gym, I suppose. We're watching this online. We don't have to restrict ourselves to a school building. So if we want to use the fundamental counting principle, we have to explain why these 2 things are independent. Our choice of letters doesn't matter, nor does the number of digits. We have the same number of options for each thing. So we have a first letter, and we have a second letter, and then we have a number. So how many letters are in the English alphabet, A through Z? Well, that would be 26. Since we can have the same letter, it would be another 26. And lastly, if we have digits 0 through 9, that's actually 10 different digits. So these are some big numbers. We're going to want our calculator ready. So 26 times 26 times 10 is 6,760 possible locker codes. I don't want to use the word combination because a combination lock is actually not a combination, as we will find out in our next video. So this is where we're going to pause our lesson. In the next video, we will look at permutations and combinations.